nomenclature. At the beginning of the year, you actually did see this when we diagrammed out the difference between elements and compounds. So if you just want to go back there in your notes and write down some general patterns and trends for how to name. You've named things before, regardless of whether it's Gen Chem or Honors Chem 1, so some of this is good review. And then we'll dabble in the polyatomic ions that you already learned based on the periodic table, that's review. And then we'll introduce a couple new concepts. I do have extensive nomenclature practice that we're going to try and do in class together. Extensive meaning the more repetition you have, the seeing the patterns and trends. And this one is legitimately just write the name or write the formula. There's nothing else to this module in essence. So it is going to go fast. I'm thinking potentially even by next week, if not even earlier, we could be done with this entirely and moving on to chemical reactions. Yeah, I know, big deal. I know, but there's really not a lot to it.
Oh, I saw that. Isn't it like hundreds of
whole
questions?
unit is
329.
Oh
This
my
is just named.
god.
This is just named.
Wait, no, 345.
If you reflect about the lab experiences you've had, there have been very few, namely, and that was my fault to be gone for a week. It kind of put us way behind schedule. If it takes us 2 days to do the lab, which is fine, there's no problems with that, it's actually 4 days of class time, right, since it's block schedule. So every time we do a lab, we lose about a week of content, and you lost a week of content with me because I was sick for a week. So we're every time.
It's actually like 2 weeks.
Yeah, we've actually kind of been about 3 weeks. So we're playing a little bit of catch up, but that doesn't affect you because I'm just pulling out parts that were kind of cool to talk about and not necessarily talking as much about those, even though we've gone a lot of side tangents. You're still getting all the curriculum you need. The organic chemistry. When we get there, you will not be responsible for the ACS, although it's really valuable. It really is in terms of even reading medical bottles, potentially for your own kids someday, doing a little bit of research about medical conditions or illnesses. It's all organic nomenclature, largely dictates that. So true biochemistry and organic chemistry have a ton of systematic naming that goes into it. So we'll dabble in there. And then after the seniors leave, see ya, we might revisit it just for fun and try to dig into the organic and biochemistry a little bit more to make it a little more applicable. But we'll hold off on that till the end of the year. Okay, how do you know the difference between an element and a compound?
An element is by itself.
So it has a single elemental. Oh man, always talking so long. My marker's dry.
Throw it away so you don't do it again.
I should.
Okay. As you can see,
You should.
it's walk away.
Seriously, all these markers.
I
are-
think I did that yesterday too, and it actually made me mad while I was trying to do it.
Yeah. Oh, that's such a beautiful marker. Don't forget about Hofbrinkel, homonuclear diatomic molecules. So anything that has a single elemental symbol that shows up on the periodic table as a single elemental symbol, but a di-molecule, a diatomic molecule, that's Hofbrinkel. So still an element. A compound, different though. This would be sodium oxide, right? Or carbon dioxide, molecular versus ionic. The difference between ionic and molecular is that you have a metal binding to a nonmetal, or two nonmetals binding together. That is a good general basic practice. Is it always that way? No. So you will start seeing some exceptions, but most of the time you can sit on that fence and write it pretty nicely. So metal versus nonmetal situation. Ionic compounds completely transfer electron density 100%. The electrostatic forces of attraction between two oppositely charged particles hold the molecule together. In essence, that's what you just did. You looked at the lattice energy associated with ionic compounds, and you correlated that to Coulomb's law, or some derivation of Coulomb's law, where the magnitude of the charges and the distance between those charges impacts the structural integrity and stability of that lattice structure or ionic compound altogether. So just an equation here to kind of tangibly put some numbers to the conceptual side of what we're doing. Molecular compounds share electron density. That sharing of electron density is like a tug-of-war rope, we've said. It can be done either equally or unequally to create a nonpolar or polar molecule. Remember, there are multiple ways you can look at polarity. One way is to consider the electronegativity values, and the other ways are things like consider the symmetry or the arrangement of atoms around there. Are there any lone pairs of electrons around the central atom, etc.? So that full list of stuff we had on this board for like 2 weeks, all of that must be considered when you're really dealing with molecular compounds, the structural integrity of those. Okay. All right. What about pure substances? What's it mean to be a pure substance? Don't overthink
It
it.
only has one kind of element in it.
Yeah. It's just that thing, right? That's what pure mean, and substance just means, and for us, purpose, thing. So you can get pure oxygen, you can refine it. 18% of the air you breathe is oxygen, molecular oxygen. Of course, you could filter it out. Might be expensive to do that, so it's probably better to make pure oxygen than it is to probably filter it out and concentrate it into there. So if you take two or more different elements or compounds, you can create a mixture. 2 different classifications of those if you're thinking back. So homogeneous and heterogeneous. So 2 different compositions. Heterogeneous. Which one says constant composition throughout? It doesn't change. Doesn't matter if you sample off the top or whether you sample off the bottom, you get the same relative ratios and identities of compounds. That's homogeneous. Give me a good example in real life of something that's homogenized.
Gasoline.
Okay, I like that. So it doesn't matter whether you're the first person at the pump or the last person at the pump. Hopefully the gas, the consistency, the ratios of petroleum and additives of sulfur and ethanol in there are all constant and unchanging. Heterogeneous mixtures, relatively a good example of this, just everyday life is sand. Pick up a handful, you reach right back down, pick up another handful. We're not talking, do they have the exact same amount of sand? We're talking about the ratios of iron and silicates all in there, right? Carbon, sulfur, other rare minerals and ions that could also present themselves. No, definitely not. So orange juice with pulp, and hopefully most consumed beverages out of a can, right? Arguably, except for like boba tea. Boba?
Boba.
It isn't boba. It's boba tea.
No,
Boba.
boba. Boba.
Yeah.
It's 2 syllables.
Right,
And you
boba
mess
tea.
it up.
Yes.
It's only 4 letters. Boba.
Yeah, it's true. It feels like it should be more than that. Boba tea. It's definitely not a homogeneous mixture, right? Everything settles out to the bottom, nonetheless. Okay. That's a review. All of that was back earlier whenever we were taking notes. Now let's add into it the systematic naming. Whenever you name elements, it is literally just the elemental name. So if you want to name Na, you say sodium. How do we distinguish between saying O versus O2? What might you say here?
Monoxide.
No.
Is it still just? Wait.
You're going to say something like oxygen. You could say molecular oxygen. You could say elemental oxygen, molecular oxygen, just to denote slightly different variations in those. So similar thing. Nothing too complicated. Here, you did have to learn or remember the 46 or so that we covered. Remember those little common ones like manganese and magnesium, fluorine versus fluoride or versus fluorine, right? All those little subtle differences. They are what they are. How do you name a mixture? You literally say it's a mixture of gasoline and water and oil and dirt and sand, and then you dump it into a pot and recycle it, right? Or you come up with a new name for the mixture and you call it orange juice, salad dressing. It's like, yeah, those are mixtures, right? Nonetheless. Okay, we'll need to do a little more with this, so you might just put a word here for now. We haven't talked about it. We will talk extensively about solutions. It's very important in chemistry. We also use the word molarity here. You might have remembered or seen that before. It talks about the relative concentration of stuff in a solution. Solution just being having some sort of liquid-ish type phase state component, but things are being dissolved in there to some, hopefully, constant composition throughout. All right, molecular versus ionic. Whenever you're dealing with ionic compounds, you need to consider, it doesn't mean you're going to use always, it means you need to consider using Roman numerals. Wherever you're using a molecular compound, you need to start thinking about prefixes. Again, it doesn't mean you will always have a perfect scenario that a prefix occurs, but you need to consider using a prefix. Yes? Okay. All right, let's go with our prefixes here. Keep going. Mono, di, tri. So this would be 1, 2, 3. Keep going.
Hold on, I'm writing it down.
Before that,
Quad.
that's true. I'll change it.
Tetra.
Tetra. You could do quad, but we'll do tetra. Mono, di, tri, tetra, penta is 5.
Hexa.
Hexagon. Hepta or septa. I've seen septa. That would be 7, but we'll do hepta. Keep going. Octagon. Nona or non. Yep. And we'll stop at 10. Deca. Okay. The question here is, why do all these have the A? You're actually going to drop these off. And when we start naming organic molecules, you don't need to write this for now. We actually changed it to something like heptol, hexol, pentol, with a YL sound there. It is YL, not L sort of notation. Okay, those are your prefixes. Nothing too crazy. It doesn't matter if you're nonpolar or polar, you use prefixes and name it the same way. Okay, so let's do a few examples here. CO2 would be, of course, carbon dioxide. If you're looking at that handout I gave you, what it says is establish the prefix of the first. So the question here, or if we're following the systematic way to name on that handout, it would say take the prefix of the first, the name of the first, the prefix of the second, the name of the second, with the ending IDE. Okay, that's how that lays out on your chart if you're trying to follow along there. If the prefix of the first is distinguished between, based upon what those subscripts are. So notice mono implies this and di implies that. So you have one carbon and you have 2 oxygen containing atoms, or 2 oxygen atoms in that molecular compound. The I ending is just part of the systematic way that you're going to actually end up naming almost all of these additionally as well. So why do we not say mono here? Take a guess.
It's implied that
It's implied. So whenever you have a subscript of 1 for the first atom in the chemical formula, you do not need to say mono. Now, as time history has progressed, scientists have kind of veered off of the naming system to kind of create new naming systems. We're going to let's just keep it basic. Let's not worry about how those derivations occur. This would be sufficient for us, okay? What about CO? What would you name that? Okay, I like it. So no mono, right? This would be carbon, and then you have a subscript of 1 implied on both locations, and then monoxide. One of the things, and it's not a huge deal to me, it's just more of like a learning process. Notice that there's a double vowel there. How would you really say that?
Monoxide.
Mon.
Oxide.
The double O sound in English?
Monoxide.
Yeah. Ooh. It's like ooh. Yeah, so you need to drop the O off of the prefix. Don't drop the O off of the word, oxygen, but you literally need to drop the O off of it. So are you going to be in big trouble if you don't know? Absolutely not. And that's the same thing with all of these A's. You drop the A's off of them instead of the O on there. Okay. How do we know where to cut this word off, ox, versus anything else? So legitimately, you could have guessed that because you've seen this before and you've seen this before. But let's go ahead and just try to play with it for a second. So what do you call it when you just take off 1 letter each time? Isn't that a name? Don't remember.
Oxidized.
Yeah.
Oxidized. Oxide.
Right? Legitimately, I would phrase it like this. When you get to a word and you're like, what is that? How do I say that? You and your partner will narrow it down probably to 2 options, and you'll just go whatever phonetically sounds easiest to say or rolls off the tongue the simplest. So oxygen, I have no clue. I was publicly educated. Oxygide, right? And eventually you could get down to maybe, I can make an argument that, yeah, you know, I kind of like these 3. Oye? Yeah, not so much. Narrow it down, look it up, learn it the first way, and roll with it that way. Okay. All right, let's do some other. I'm going to make these up. They may not, you might make a note of that. These may not actually exist in real life. I'm just going to put in random subscripts so that we can have a plethora to choose from. But we do know this one. All right, go ahead and name these.
That's really is phosphorus.
That's phosphorus. Yep, that's phosphorus.
Phosphorus,
Pentachloride.
Pentachloride. This one.
Sulfur.
hexafluoride.
Fluoride, right? Not
No
fluoride.
B,
Fluoride.
No one says fluoride.
But you'll spell it as fluoride.
No, I won't.
Sulfur
Xenon.
hexafluoride makes you a real man.
No,
Right?
you don't
Okay, so a
inhale
lot of
it. I
those
put it on a
begin with the
spoon.
mono prefix on the first.
That's why I said 5.
Okay, do this
What's
one.
one cold?
Disulfur,
There you go. Disulfur.
tetrafluoride.
Phosphide, right? Again, making some up just for the sake of argument here. Let's do this one.
Pentanitrogen.
Pentanitrogen. I like that. Pentanitrogen.
Oh,
Pent.
pentoxide.
Pentoxide. Good, good, good. Not too crazy, yeah? I mean, in terms of the basic systematic way to name those, pretty good.
So the first element will always just be the name of it.
The full name.
So
Full name of the first.
pentanitrogen.
All right, let's do your ionic compounds. Let's just vaguely remember here how to name these special polyatomic ones. There are a few that you don't get off the periodic table. H3O plus and NH4 plus, those are two common ones we use. This is hydronium. The acid, this is the basis of acid-base chemistry. Shows up in your gut lining, hydrochloric acid in here to help dissolve and denature proteins. Shows up, so this is the hydronium ion. If you were to just say hydronium, that is correct. You don't have to officially say ion, unlike some of the other parts of the naming system we'll do in a little bit. So this is ammonium, good. Non-ammonia. What do you see? What is ammonium used for in real life? Well, sorry. Okay, good. Clean. That's ammonia, although there are ammonium salts in there for sure. Fertilizers, right? You're getting ready to plant various crops throughout different seasons, and you see a big old what looks like a propane tank out in the center of a field. Ammonia fertilizers. The guy who invented this revolutionized legitimately agriculture as a whole. If you have 7 billion people in this world, and they measure crops yields in terms of bushels. So back in the day, maybe you had 15 to 20 bushels of wheat per acre. That's not a lot. Nowadays, you could push 30, sometimes even 40 bushels an acre. So you've ultimately doubled the amount of grain that's available for mankind, ultimately because of fertilizers, pesticides, herbicides, etc. The downside of things like that is ammonium derivatives are also used in explosives. So literally changed World War I. You now have bombs being created, and so arguably the Nobel Prize originally was created because whatever his first name was, I don't remember. Nobel, whatever it was. I don't remember. But he came up with the process of fixing nitrogen in compounds for certain purposes of agricultural, industrial use, and ultimately came out to be a precursor of TNT, so explosives, and that he saw the devastation of millions of hundreds of millions of lives being lost, so he developed a Nobel Prize to say whoever has scientific endeavors use them for good. So in a similar way, changed the way agriculture is done entirely, but total massive devastation additionally with some ammonium-containing compounds, nitrogen. All right, those are your positive ones. There are hundreds, literally hundreds more, but those are the two most common ones. All right, say the names here. The first one? Hydroxide. The second? Acetate. This is vinegar. This is Pepto-Bismol, some derivatives of it, calcium hydroxides, etc. Nitrogen. This is nitrates, preservatives.
Is that an oxygen?
Where are you at? Yeah, sorry. Nitrates. Those are your -1 charges, carbonates, sulfates, and phosphates. Kind of the, if you will, these are the basic ones. Again, there are hundreds of others. Now, each one of these names, when we're looking at like nitrogen, oxygen, carbon, oxygen, etc., remember there's a periodic trend for those. So I'll just say that, use the periodic trend that you've established. When you are naming the 8th form of these ions on the periodic table, what's the pattern you apply? The 8th form. What do you do? So if you're just looking at boron, carbon, nitrogen row, and the fluorine, the halogens, how many oxygens should be combined with those atoms to make the 8 form? Boron, carbon, nitrogen, fluorine, chlorine, bromine. How many?
3.
Yep, see, 3, right? There's our carbon showing up as 3, there's our nitrogen showing up as O3, etc. So on the periodic table, I'm just going to do it like this. This top row, boron, carbon, nitrogen, and the halogens, fluorine, chlorine, etc. This is your O3. That's the 8 form of everything. Then everything else that's in here is O4 for the 8 form. If you want to say per 8, what do? So per, let's say, chlor 8. So chlorate is ClO3. Has a minus charge. What's per chlorate?
-2. Oh, you mean. Wait.
Per chlorate?
There's a lot.
Yeah.
It's been a while. That's alright. Slide this over.
Oh,
Oh,
Oh.
perchlorate,
per chlorate.
chlorate,
Chlorite? Hypolite?
chloride.
So which is which, though?
So perchlorate has ClO2. 4.
Yeah. One more. And then chlorite,
is
ClO2, ClO, right? And again, just because we're naming these doesn't mean all of these exist in terms of a stable form. You may not see one of these very often in general. So how do you get this negative sign? How do you get that?
That's how far away it is from
That's its proximity to
noble.
a noble gas. But how do you get the negative sign for nitrogen? That is
It's
not one
proximity
position.
to oxygen.
There you go. So boron, carbon, nitrogen is the proximity to oxygen. The rest of those meaning everything else that's a non-metal is its proximity to a noble gas. So chlorine is one position away. Keep the charge that's associated on there. Let's just for simplicity, not simplicity, but for argument's sake, hey, there's a face on my board. Where'd that come from? Has that been there?
Yes.
Like for days?
No.
Oh, okay.
I think it
Yeah.
was it days?
Yeah. What's the oxidation state of oxygen in each one of these? Oxygen, most likely. Don't
What
know.
was your question? -2?
-2. Yeah.
Yeah.
Basic, yeah, not face state, oxidation state, but -2. So -2 times 4 is -8. What must be the oxidation state of chlorine in order for it to be a -1 overall?
Positive 7.
+7. So +7 plus -8. What's the oxidation state of chlorine?
Positive 5.
Here?
Wait, what?
There's a trend,
Positive 3. And positive 1.
right? So just looking at, does the oxidation state of the atom in these compounds change? Absolutely, it has to. Absolutely has to, for sure, if these charges are remaining the same. Okay, so those are your special polyatomic ions. There are others, like you don't need to keep track of this right now. If you ever have something that shows up kind of weird and you're like, wait, what is that? I would give you the name initially to start with. So things like thiocyanates, cyanide, that sort of thing. Potassium permanganates. So manganate ions have things like this. Yeah.
How do you know if it's a neon ion?
If it's a what?
A neon.
A neo?
Like where it has the neon.
Hydronium, ammonium.
Oh,
Neo.
Yeah, I was like, Eum. I really thought you were saying Neo, and my head went to Matrix. I'm like, what is she talking about? Matrix, Neo? I was like, Eum. It's special or specific names, Eum, for us, although there are systematic ways to begin to name those. Miss Lefevre, I think, had maybe an extensive list of ions or something. I don't have it for you. But there are literally, and I know there's no joke, thousands of different ions, special polyatomic ions.
So if there's special names for like the polyatomic,
Yeah.
because it says cation or anion, it's a special name.
Yeah, special
Just
names,
give it to us.
these are sufficient for you to know. So use the periodic trend or those on the board, otherwise I need to give them to you, in essence.
So
Yep.
we need to know the per.
Yeah, the per eights, the hypolites.
I think good for that.
I think you guys saw that maybe back in somewhere, chapter
We did.
2-ish, somewhere there.
Mine has had a name.
All right,
on it.
let's name here, that leaves us with these, the monatomic cations and anions. They're named using, one of those is named using Roman numerals. If you're looking at your flow chart there, the monoatomic cations are the ones that need the Roman numerals. The monoatomic anions do not. So let's try to do the cations first. You'll need your fancy periodic table out.
Good to know.
Yeah. On your fancy periodic tables, I think we might have pointed this out once or twice. You're not going to be able to see this, so I'll try to tell you where it's at. Find the atomic mass or the molar mass of any atom, it doesn't matter. And directly below that, on yours, question mark? Yours the same as mine? Yes. Directly below that, the molar mass are numbers. They're either positive or negative, or both, and one of them is in bold. So look at oxygen. What number is in bold? Actually, that's a horrible example. Look at nitrogen.
1.042. 43.
I'm looking at the plus or minus. The plus or minus 3, 5,
Oh, that's the
4,
oxidation
2. Those are the oxidation states. So that means nitrogen could be a positive 3 if it loses 3 electrons, which it has 5 valence. It could do that, or it could lose 5 valence electrons to look like a noble gas. It could gain 3 electrons because it has 5 and it needs to get 8, so on and so forth. So those are your oxidation states. The one that is in bold is the most common and most likely to occur. So you start there. Whatever's in bold, use that first. Now looking at some of those, go to the alkali metals, sodium, potassium, etc. What do you notice about their oxidation states? You never have an exception, right? So keep track of that. Alkali earth metals, column 2A, always a
2.
no exceptions. Some other things that occur regularly are the oxidation state of oxide. These are not cations, let me put them somewhere else. O2 minus is always there. Aluminum typically is a positive 3. Zinc is always a positive 2. What about cadmium?
Oh, that is all.
Cadmium. CD? Yep.
2.
It is positive 2 right underneath zinc. Silver, right beside it, is always a
1.
positive 1. And then if you keep looking on the periodic table, there are others. However, for us, these are sufficient. If you just keep track of the fact that the group 1A elements are positive 1, group 2A elements are positive 2, always, these always are true for us. Do they have to be true in chemistry? No, but for us they are. Okay, so that's a starting point as well.
Wait, those are cations.
Yeah, these are just general charges on the periodic table that you can say, if I have to talk about charges, these are consistent for us.
So those ones will always be those.
Yeah, for us. Yeah,
For
but
us.
for us.
He has to.
Yeah, because there's other options, but we're not going to get those. All right, so monatomic cations. So we're going to name this with the elemental name. So this is just sodium. This is iron. This is iron. We do need to put the word ion at the end. Why do you think we need that word ion there?
Because if it's not ion, it's
Yeah.
just neutral. It's like a neutral
Yeah.
charge.
Sodium is not in. Sodium is Na. Sodium ion is the positive charge. So it talks about its permanent charge that's there. Notice that we have a problem here. How do you know the difference between the oxidation state of positive 2 and positive 3? One does chemistry one way, the other does chemistry a different way. You get two different results. So if you ask somebody for one of these iron ions, they literally need to know, well, which one. So you put a Roman numeral in here. So you're going to put in a parentheses, Roman numeral number 2, Roman numeral number 3. That Roman numeral denotes what the oxidation state of that ion is. Fair? So the iron 2 and the iron 3 ion. How do you know when you need a Roman numeral or not? If you're in the transition metals, so not the main block elements, then you need to consider using a Roman numeral. These do not need Roman numerals. Why? Because they only have one oxidation state. So if you walk up to somebody and you say zinc ion, you don't need to say zinc 2 ion, because zinc is always a positive 2 charge, so there's no reason to put it in there. So only use, so this is what you can kind of summarize it as, only use Roman numerals when you need multiple oxidation states. If there's a multiple oxidation state, then you need to use a Roman numeral. So no Roman numerals for these cations that show up on this list. This one would be what? Magnesium. What would we put?
Ion.
Yep, because it's in group 2A. This would be copper 2. She's a nice blue color, blue turquoise. Copper 1 is kind of a dark black, brownish color. The Statue of Liberty is what color? Yeah, blue turquoise. They have to acid wash her every so often. She goes through a redox reaction. So it takes electrons or puts electrons on depending on what surface is exposed. So they go over her and try to reverse the process to keep her turquoise appearance. Not that we want to be okay with that. It's just originally when it was given to us, it was a certain color, and it's like, iconic. And it's the Statue of Liberty has a certain color.
What color is it turning into?
Blackish brown.
Okay.
Yeah.
That'd be cool.
It would be. Yeah. Cool. All right.
It used to be completely brown, right? Like shiny brown?
I mean bronze. Is that what you're thinking? Copper, bronze color? I don't think originally. I think she came over turquoise. Did she? I don't know my history well.
It was a gift to somebody else first, and then the dude was like, and then the country rejected it, and then the dude was like, oh well, who do I give this to? I guess America.
Oh.
Wow, we got the hand-me-downs.
Yeah.
Your first photo is right here too, though.
It's not. It's not. We need to go to Alexander's right now. You go to
Just Google it.
That's what
Let's
I'm
just make up
doing.
history.
All right, monatomic
It doesn't matter.
anions. All right, so those O2 minus, they have to be anion, meaning negatively charged. What's mon mean?
One.
Mon?
Morgan, what the heck?
What's that?
The first rib is the most curved and usually the shortest of all ribs. It begins from thoracic vertebrae T1. It articulates with the sternum just below where the collarbone meets the sternum. It has muscular attachments from the serratus anterior and the anterior scalene.
Right there. Push on that. It hurts. Feel it. Feel it. Everybody try to pass yourself out.
I
Push
just
on that
looked it
hard.
up.
This is on.
You know, I think I'm fine.
You're
Right.
fine.
Same.
Why
It's
not?
right- it's-
I was
That's
literally
where
born
your,
with an
like,
affected
rib cage
heart. Maybe let's
begins,
not
though.
make
So
myself
it's like
upset.
right underneath your
Just push hard. You'll cripple somebody.
It hurts.
Okay,
There's
mon
a whole
medium
martial
1.
art where they literally just do pressure points.
Yeah.
So it can,
Well, I have a sore throat sometime in mine.
okay.
Mon meaning 1, atom meaning atom, and then anion, so negatively charged single atom. That's what you have here versus polyatomic, meaning multiple atoms making up some sort of charge. Nothing crazy here. Do the same thing you did for binary compounds that were covalent. So this is, instead of oxygen ion, it is the oxide ion. Instead of sulfur ion,
It's sulfide.
it's, sulfide ion. So how do you know what to cut off? Again, whatever sounds good.
Chloride.
Chloride ion, and this is the nitride ion. So do you need to say the word ions here? No, you don't. You can say oxide, sulfide, chloride, and everybody in the scientific community would know. It's more just clarifying, be like, hey, use the oxide ion. It's like, oh, that helps, thank you. Talking about a -2 charge overall. How do you determine these oxidation states? It's the proximity to the noble gas is what ultimately determines that, right? Nothing crazy there.
Wait, so what would 33 be?
What's 33?
Arsenic?
Arsenide? Arsenide?
Oh, curious. Interesting.
Yeah.
Silicon.
So much good knowledge. All right, now putting them together. You've seen this multiple times. You've called this sodium chloride for many years. But the question is, why did you not use the word ions? Because if I'm naming this is the sodium ion and the chloride ion. That's what you have here. Why not these words?
Just to get it.
It's electrically neutral, and this is not an ion. If this was an ion, what should we see? Some sort of charge here, right? Those things do happen. You legitimately could take carbonate, 2 minus, add a hydrogen ion. You would form HCO3. What would be the charge? If I took a positive charge, this is just a proton, no electron, no neutron. So if I took a proton and added it to something that's -2, -1. And if I did that process,
Right? -1.
and did that process again, so this would be carbonate. This is the bicarbonate ion, and this is carbonic acid, and it can dissociate back into here. If we release, oops,
There's a lot of arrows going on here.
yeah, if we release some hydrogen in the process.
Oh, that was curvy.
It was. So
Like,
nice.
look at it.
Branching out in my artistic creativity.
Yo, the arrows,
Yeah,
lines. Can't even draw a
Yeah.
page.
can't do it.
That does not
but
bring an E.
This is the ion. This is an ion. These are special polyatomic ions. Carbonate. There's a special name for this, the bicarbonate ion, or you could call this hydrogen carbonate ion. But you would say the word ion, right? Because the charge is there. You don't say dihydrogen carbonate ion. That wouldn't make sense in that setting because it's not permanently charged. Okay. So how do you name? And we're going to call these ionic compounds because there's electrostatic forces of attraction between them. Compounds. Let's do a few others. Let's make them a little bigger here. This is not balanced, but let's name it. And I want you to do that because I want to prove to you the name is not influenced by the subscripts for ionic compounds. So
It's like ammonium.
this is ammonium.
Carbonate.
There you go. Now, if we were to draw ammonium carbonate, it would be absolutely essential and necessary to go ahead and balance it. This would be 2 here. The ammonium ion is a positive 1 overall. The carbonate ion is a negative 2 overall. So 2 different positives balancing out the electrically, or creating an electrically neutral species, ammonium carbonate.
Question.
Yeah.
Do not.
Do you? Huh?
Do a what?
Oh, I thought you were telling me. Anyways, do you have like a list? Like Miss Davis had a list for like all of the compounds
What type of list?
with the oxidation states of the list.
You got a trend. We don't need that list.
I
yeah.
say we need the list just
You
so I
got
can
trend.
figure out the trend.
Yeah, I love the trend.
Teach
Yeah.
the trend
We'll do patterns, trends, and relationships.
tomorrow.
What about this one? What about let's say
I
iron
just ignored you.
to phosphate. It's deflection.
It's working so well. We are all very aware.
Yeah, I know, right?
Morgan wants this water bottle on that side of the room.
What? I'm so confused. My water bottle?
You want my water
I think
bottle?
we should
do it
This
that
side of the
fast.
room.
What's happening right now?
should go
Miss the
Fevers.
Can we please go look and investigate because they're really loud.
I think we should all just like stick our faces up against the windows
You know
until
what
they
we
look
should do?
over.
No, we
It
should
would be
just
awesome
scream
No,
at them.
if we
he's
all
barking and I
run out the door and
Yeah.
tackle
Like
somebody.
charge.
We all just charge at Lakeview.
Not leave her, leave her.
Not
alone.
gonna
We all just go tackle.
Who is in this class? Like what class?
Looks like
Wait,
sophomore.
no, she has physical
You know you should
science.
do? Sunday should make a science.
She is freshmen right now. They're freshmen. It's physical science. I think Nina's her age. Nina is maybe
All I
They're
heard was
freshmen, you
like,
can tackle
You
them.
guys didn't hear
Oh, they're like actually doing
Oh,
science.
they're actually like
Yeah, we
doing
can't just
something.
throw
They're
them
not just
all.
out there.
If they weren't, then we would. Yeah, she's such a good teacher. She lets her kids play outside. But anyways,
No, she does
No, she does.
We should
though.
take a
I used
pop
to see
in
her
her
class.
I bet Morgan. I also
I
bet
don't
you.
have a politics.
Morgan, I also bet you that she lets her dog sleep in the house at night.
No, I bet you.
Hi.
Your big head's always in the way, so
Mom,
I
what?
don't understand.
No, I think it's really just your whole body. No, this is
No,
exactly.
because you write it down and then you're just like,
had it paused
okay,
for
and you stand right in front of it.
No,
I'm
that's
like,
not
"Oh,
what
I wrote
happens.
it down."
He writes it all and then he stands right there and he's like, alright, so I'm gonna watch everything you
There's 2
need.
reasons for it. One is I don't want you to look yet, and I want you to
What do you
stick
mean?
here.
No. You already talked about it and you were just finishing up writing and you're just blocking the whole thing.
You'll know when I want you to look, because I'll do one of these things.
You'll know when I want you to look.
Yeah, I do one of those things though.
I don't think you do that very often.
I do this.
No,
Does that hurt?
please start putting.
That's it, like a
That's
point.
the highest it's ever gone before. Really. Wow. Alright, we're okay. That hurt my 12th rib.
You mean you're 13?
You can reach that if you just grab here. And
Morgan, it'll be my
Yeah.
13th.
Yeah. Alright.
Yeah, let me just like shove my hand
I can
into
do
my
that.
into my rib. No, I meant like legitimately into your body.
So iron 2 phosphate,
Just like
the Roman numeral number 2 denotes the oxidation state of iron, and phosphate is a -3 charge overall. You would have to either use the periodic trend to get to phosphate's -3 charge, or memorize it, one of the two. I argue the trend is probably a little better. Iron 3 phosphate, now you need to balance this equation. So if we need 3 different +2 charges and 2 different -3 charges, remove the charges from there. If you want to put them in, write them over the tops to denote oxidation states. But why do you need a parentheses here for a 2?
because if you put it on the oxygen again, there's
Yeah.
only
Yeah, so you don't put a parentheses here because there's only one atom. That wouldn't make sense. But if the 2 applies to the entire compound or molecule ion, then you need to make sure there's a parentheses around that. Okay. All right, let's do a couple other ones. Let's go manganese 4. Manganese 4, Roman numeral 4, and let's do carbonate. All right, go ahead.
NN 4 plus CO3.
Okay, CO3, and that's a 2- charge. So we need 2 of these. Okay. All right. Arguably not simple.
Wait, I don't know what this. What's the state on manganese?
+4, yeah. This
Okay.
part,
Because you're like G's and
So again, not simple. That's not what I'm arguing. I think I'm just arguing straightforward. Not crazy things happening here. If you have the Roman numeral, that's the oxidation state of the first. You have a polyatomic ion that you either use periodic trend or you memorize. Okay. All right. Should we do a little practice? Let's do it. Let's do this one.
Holy that's
Don't
not
look
a
at it.
little practice.
This one. Let's do this
That's a
one.
lot of practice.
This is writing the chemical formulas of these. Come grab one of these.
Man's got a whole 20 questions, guys.
Yeah, we can do it.
I can, but does that mean I want them?
This is the right one. I want the extensive practice.
I feel like we already passed
What the
most
fuck?
of these
This
out.
is too easy.
She really
For
took the
real.
whole file
Ferric hydroxide.
from
Yo!
the middle of the stack.
Which one is
Not
ferric
even
and which
you
one is
one.
ferric?
Middle of the stack.
I can't remember.
Ferris, bruh.
It was
Did Maddie get
sticking
one?
out.
Yeah.
Wait, then who didn't get one? You two?
Yeah, we should have happened.
Oh, we got it.
Literally only you.
Oh, thank you. Poor Jason, he's been gone.
He's been gone. How does that have anything to do with him grabbing a sheet of paper?
Calvin was gone yesterday, right?
No.
Okay, Calvin, I did that.
Yeah, did you
Right.
second back?
Right.
Did you
Literally
do
was here
attendance
yesterday.
yesterday?
We talked about how he was here yesterday.
Yeah. I
Yeah, we
remember.
literally had a whole conversation about it. No, but you should tell us about your mental arts thing.
You know, I can't believe I never told you this. Sorry, these are true stories.
Oh, yeah.
Ooh.
The fact that you have to state that before you say it. It's like a
That's
disclaimer.
Red
You
flag,
lie
red
a lot,
flag.
Mr. Morgan.
That's because you're
It's
not
a
gonna
red
believe me.
flag, Morgan.
Yeah, you're not. I gotta get you a picture though.
Brody.
This is.
Are we just naming them? Or are we finding oxidation? Like, what are we doing here?
Right
Also,
in the
this is not a
chemical
real name. That's
equation.
just straight
Yeah,
up
right,
copy
the
work on
balanced
paper.
chemical formula.
Do you have answers to these?
Yeah.
Or will you just leave me in the dark?
Yeah.
Paper.
Yeah, like, you can tell us what we're even
Wait, did
writing.
you
If
ever
are we
release the
naming?
exam
Are we-
review answers so we can actually see if we got those
These
right?
ones were right.
So we take that exam with you.
Oh, I didn't know they were different. I just assumed.
No, I forgot to get it last night.
No, like, I didn't even look at the paper, I'm gonna be honest. I looked at, like, the first question.
Is the exam
exam
retake
review?
due
How do you know
Wednesday?
what atomic
Would it be due
molecular?
Wednesday evening
You
instead?
wanted us, I wanted him to.
Or any of that?
Thank you.
Yeah.
I appreciate that a lot.
Oh my god, thank you so much.
We have a
What
Midwest
is y'all
tomorrow.
doing?
and it's
So,
not-
Dude, I'm
yeah,
telling you.
no one did right.
Yeah.
Yesterday, English was so fucking boring.
I'm gonna be in this
Me and
experience.
Josh
So,
started
just be
drawing
ready.
mailboxes.
Bruh.
Hey Morgan,
Huh.
is chromate supposed to be like
Fine.
Rickon or something?
No, on some of those,
What do you mean, is it from?
actually on some of those you might have to Google the ions unless you have an ion sheet.
But it's in the.
See, that's why we need an ion sheet.
What's the
Well,
story?
don't we have
You were
like
gonna
the?
go
Yes, we have an
about
iron.
that.
We do not hate it.
I,
Oh my
I got
god.
sidetracked
It
in
is
chromate.
Peter.
Dude, you
Instantly
never even told us
recognizable.
your freaking story.
Well, no.
You're getting sidetracked from a lot of things.
That is true. I was trying to help you with the history. You're right.
Yeah, don't do that.
Okay, don't help us. What do you mean?
CR
You don't do that
04,
anyway.
-2.
It's CR though, where's that?
Can you do K?
Yeah,
Peter.
chromium
Chromium.
is
it's 24.
Yeah. Alright, true story.
The disclaimer.
Shelley Ann Fraser.
Oh, I thought you were just FF.
Maybe you did tell us this.
I did right. I'm sure.
I don't
Oh, I don't
know.
Chemistry people have never seen this. Matt, you seen it? This first. Alright, this is Shelley Ann Fraser Price, the world's fastest woman from Jamaica. She's won the 100 and the 200. Didn't really care about who she was. I mean, I did not care about who she was. Did I?
Yeah, I don't remember that.
Oh.
You were on a mission trip or something?
Yes, that's
Yeah,
it.
you
I
told us
told
that.
you I challenged her to the world's fastest race.
You guys don't remember this?
Oh, you mentioned it for like 5 seconds and then we moved on.
Yeah, what was actually? You know what?
I don't remember this at all.
You don't remember it?
Oh, you met. Oh, so you met her when
I
you
didn't
went
meet
to-
her. I challenged her.
I
You
remember
won.
that, and then
Let
you
me find
brutally
it.
lost.
Let me find
You
this.
told me
Is
he
arguably what I was looking for. That was what I was doing. The short version is, I end up in Jamaica, third world country. She shows up, didn't know who she is. Asked a lot of people about who this lady is. She's getting ready to walk out after an hour and a half, and I just walked up to her. And I'm like, "So, I hear you want to race me." And that's what I said to the world's fastest lady. I didn't say hi. I didn't say how are you. Didn't ask for an autograph. I just straight up said, "I hear you want to race me." She doesn't even know who I am. I kid you not, on Sunday, this past Sunday, I'm sitting there with my dad watching the basketball game, and this popped into my mind about something somebody said, and I looked over at my dad, I'm like, "Dad, do you think Shelly ever talks about me?" To her friends the way I talk about her to people here in America?
Just like this random guy challenge
Yeah.
me one day.
And my dad's like, "No." Like, you don't think she like mentions that crazy American that she turned down? Anyways, she lost a few races, but picked it back up. She had a kid now, so I really feel like I've inspired her in a lot of ways. I feel like she's done
Quick question.
great
How does
success.
this have anything to do with the fact that I mentioned martial arts? And then you said I have a story
There
for
it
you.
is. All right.
Okay, I was like, how does that have anything to do with
Noah
the story?
Goddard.
Like, that is not who you wanted to talk about when I mentioned martial arts.
The SOP.
2003. I don't know.
You just retyped three times.
I did. I don't
Oh yeah,
remember. Oh wait, the time
What?
signal. Maybe that was it.
How do you spell it? Or how do you?
For the first one.
That's fine.
Uric acid.
No, that was pure guess. I don't know.
Morgan, you gave
How
us
do
an
you-
assignment that
potassium
we
ion.
went
Wait,
over
which one are you
things.
living on?
Hang on. Let me tell you my story.
That's not even potassium.
I
It's
don't know.
phosphorus. I was like, that's not even potassium.
Anyways, there was a kid.
Potassium's not on
I was
my
in
metal, so it's
Sandel's
different.
psychology class,
Like
and
taking it
this,
or-
yeah, I was taking it. He's
It's a
old.
metal.
Yeah. But I'm not. This is,
But I'm not.
and I'm sitting in my seat like day 2 of class, and this 6'3" fortress of a man, like legitimately just a towering, solid mass of muscle, sitting behind me, and I'm like making casual talk with everybody around me, and then somebody's joking, and then says no. I think his name was Noah. I don't even know. And he's like, "Hey, dude, how'd your event go?" And so I kind of like eavesdrop. He's like, "Oh, I didn't make it. I missed it by 1 place." I'm like, "Missed what?" He's like, "Oh, I missed qualifying for the Olympics in karate by 1 place." And I'm like, "Wait, straight up? You straight up sitting behind me right now?" Like, that's super cool, but I need a new seat. You know what I mean? Like, I'm like this guy, like, start kicking my desk. I'll be like, "Hey, bro, what you doing?" Wow. And I'm out. You don't want that. So I said, after class, I need you to show me something. I need to learn something from you to say that I've challenged an Olympic athlete. This was pre-Shelley and Fraser. This was in my mind back in high school. Shelley and Fraser was in college. I have something with challenging Olympic athletes. I don't know. Anyway, so he's like, sure, after class I'll show you something. So he goes out in the hall, and in between passing through, I'm like, now do something to me, but don't actually do it. Because I know that if you do it, I'll get hurt. And he's like, I can't not hurt you. That's what he said. He's like, I can't not hurt you. I'm like, but you have to not hurt me. I just want to be, it's not that hard. Just show me what you would do, but don't actually do it. And he's like, fine. And so he's like, here's what I'm going to do. He says, I'm going to take 2 fingers, I'm just going to push on your chest. And I'm like, well, how hard are you going to push? And he takes my arm and he kind of does like one of these things. I'm like, oh yeah, that's fine. No big deal. You do that. But only that, right? Dude pushes on me. I drop to the floor. Can't breathe. He's sucking air. I'm curled up on the floor beside the lockers with this 6'3" Olympian. However, he's like, you all right, man? Yeah, I'm good. I'm good. Straight up. So I did lose that battle.
Oh my god.
I won Shelly and Fraser, so it's
No
really
battle. There was a
it's
battle.
really a wash at that
Oh
point,
my
isn't it? You know what I mean?
God.
That's right.